Section 1. On June 22, 1941, the Wehrmacht unleashed the largest military operation in human history, sending 3 million men and 3,000 tanks across the Soviet border. To the casual observer, this was the apex of the Blitzkrieg, a seemingly unstoppable mechanized tie designed to crush the Red Army in a matter of weeks. Yet, hidden within the logistic tables of the Oberkommando des Heeres, OKH, was a fatal mathematical discrepancy. The invasion was not doomed by the Russian winter or the vast reserves of Siberian manpower, but by a calculation error made in Berlin long before the first shot was fired. The operational plan required a reach of over 1,000 miles, yet the logistical tether snapped at barely 500. Now let's open the archives and dissect the system that decided the outcome. To understand the catastrophe of Barbarossa, we must look past the newsreels of advancing panzer columns and examine the spreadsheets of the German quartermaster general. The central premise of the invasion was built on a short war illusion. The strategic objective was the AA line, Archangel to Astrakhan, a geographic boundary that would effectively neutralize the Soviet Union. However, when we analyze the Großtransportraum, the heavy motorized transport regiment responsible for bridging the gap between railheads and the front, we see that the Wehrmacht was attempting to solve a physics problem with rhetoric rather than resources. The fundamental constraint was the logistical apogee. In 1941, the standard German supply trucks, such as the Opel Blitz, had a specific operational radius. A trucking column could effectively supply a field army up to 300 miles from a railhead. Beyond this distance, the law of diminishing returns takes effect brutally. The trucks begin to consume a significant percentage of the fuel they are transporting just to make the return trip. The OKH planners were aware of this 300-mile limit. Their solution was a dangerous gamble. They assumed the German railway engineers could convert the Soviet broad-gauge rail network to the standard European gauge at the same speed as the panzer divisions advanced. This assumption was the systemic flaw that doomed the operation. The operational tempo of a panzer group in open terrain was approximately 20 to 30 miles per day. The maximum repair rate of a railway engineering battalion was, optimistically, 10 to 15 miles per day. When we plot these two distinct velocities on a graph, they diverge almost immediately. By the second week of the invasion, a dangerous supply vacuum opened up between the advancing tanks and the railheads that fed them. Furthermore, the composition of the German army reveals a stunning lack of modernization that is often obscured by the myth of the Blitzkrieg. While the spearhead was mechanized, the body of the army was Napoleonic. The archives indicate that the invasion force utilized over 600,000 horses to haul artillery and supplies for the infantry divisions. This created a two-speed army. The armored spearheads, relying on fuel and maintenance, raced ahead, stretching the supply lines to their breaking point, while the horse-drawn infantry lagged behind, unable to close the pocket or secure the captured territory efficiently. We must also scrutinize the sheer volume of throughput required. A single panzer division on the offensive consumed roughly 300 tons of supplies per day, fuel constituting the bulk of that mass. The entire invasion force required 60,000 tons of daily resupply to maintain offensive momentum. The Großtransportraum capacity, even on paper, could barely meet half of that demand once the advance pushed beyond the Dnieper River. The planners compensated for this deficit by prioritizing fuel over ammunition and food, a decision that essentially placed the army on a starvation diet to keep the engines running. By mid-July 1941, the mathematical illusion began to shatter. The logs from Army Group Centers show that despite tactical victories and massive encirclements at Minsk and Smolensk, the logistical pulse was failing. The trucks were driving 600-mile round trips over dirt roads that were rapidly disintegrating under the weight of traffic. The vehicles were breaking down faster than they could be repaired, and the railheads were hundreds of miles to the rear. The system was not being defeated by the enemy, it was being defeated by distance. The Wehrmacht had launched a 1,000-mile invasion with a 300-mile supply chain. Section 2. The collapse of the Barbarossa timeline was not merely a failure of planning, it was a collision with physical infrastructure that simply did not exist. When we conduct a logistical autopsy of the Eastern Front, we must turn our attention to the spine of any 20th century army, the railway. The German logistical model was predicated on the railhead-to-front system, where trains handled the long-haul strategic movement and trucks handled the tactical distribution. However, the Soviet Union presented an engineering hurdle that the Wehrmacht had drastically underestimated: the rail gauge. Western Europe operated on a standard gauge of 1435 mm. The Soviet Union, precisely to prevent the rapid invasion scenario Germany was now attempting, utilized a broad gauge of 1524 mm. This 89mm difference was the single most effective defensive weapon in the Soviet arsenal during the summer of 1941. It meant that German trains, laden with the millions of tons of fuel and ammunition required for the advance, physically could not enter Soviet territory. To solve this, the Eisenbahntruppen, railway troops, had to physically pull up the tracks and relay them to the narrower German standard, a laborious process that required manual labor and specialized equipment. Archives from the Reichsbahn reveal the severity of the bottleneck. Soviet retreating forces ruthlessly destroyed water towers, signaling equipment, and switching yards. By August 1941, while the panzer groups were technically 400 miles deep into Russia, the functional railheads were lagging 200 miles behind them. This created a supply shadow, a dead zone where the operational reach of the army exceeded the grasp of its rail network. This forced the Wehrmacht to rely entirely on motorized transport to bridge the gap. Here we uncover the second fatal systemic flaw: the heterogeneity of the German truck fleet. Contrary to the propaganda images of a standardized mechanized war machine, the German transport corps was a logistical nightmare of scavenged equipment. Following the victories in France and the Low Countries, the Wehrmacht had absorbed thousands of civilian and military vehicles from across Europe to fill its shortages. When we analyze the maintenance logs of a typical infantry division in 1941, we do not find a standardized fleet. We find a chaotic mix of German Opel Blitzes, French Renaults, Czech Tatras, and British Bedfords. Logisticians call this fleet fragmentation. It makes an efficient supply chain impossible. A division commander reported that his unit required spare parts for 87 different models of trucks and 20 different types of motorcycles. When a French-made truck broke a specialized axle rod on a Russian dirt road, there was no replacement part available in the German supply depot. The result was immediate and total attrition. The vehicle was stripped of useful components and abandoned in a ditch. Furthermore, these Western European vehicles were designed for the paved macadam roads of France, not the primitive tracks of the Soviet Union. The environmental conditions of the Russian steppe waged a war of attrition on the internal combustion engine that was as effective as enemy fire. Before the infamous mud of the Rasputitsa season arrived, the summer dust proved to be a silent killer. Analysis of engine failure reports from Army Group South indicates that the fine, abrasive silica dust of the Ukrainian steppe bypassed the standard German air filters. This dust formed a grinding paste with the engine oil, destroying pistons and cylinders from the inside out. The lifespan of a truck engine rated for 10,000 miles in Western Europe dropped to less than 2,000 miles in the East. By September 1941, the Wehrmacht had lost nearly 25% of its total transport capacity, not to combat, but to mechanical exhaustion and systemic incompatibility. This degradation of the logistical tail had direct strategic consequences. We see this clearly in the decision to halt the advance on Moscow in August to divert forces toward Kyiv. While historians often debate this as a strategic error by Hitler, the logistical data suggests it was a necessity imposed by the infrastructure gap. The supply lines to Army Group Center were on the verge of collapse. The trucks were breaking down, the railheads were too far back, and the fuel consumption for a direct thrust on Moscow simply exceeded the delivery capacity of the surviving fleet. The system was cannibalizing itself. To keep the leading panzer divisions moving, the Wehrmacht was forced to strip trucks from the infantry divisions, effectively demechanizing the bulk of the army to keep the spearhead sharp. This created a dangerous separation. The tanks were miles ahead, but the infantry, the force needed to hold the flanks and secure the supply lines, was walking, relying on tired horses and their own boots. The infrastructure gap meant that the faster the Germans won tactical victories, the closer they moved toward strategic paralysis. The friction of the terrain and the fragility of the transport fleet were acting as a braking mechanism that no amount of operational will could override. Section 3. The final verdict on Operation Barbarossa is found not in the memoirs of generals, but in the immutable laws of physics known as the culmination point. By November 1941, as the Wehrmacht prepared for Operation Typhoon, the final assault on Moscow, the logistical autopsy reveals a patient that was already clinically dead. The tyranny of distance had exerted its absolute price. The operational momentum, sustained by cannibalizing the rear echelons and burning through finite stockpiles, finally hit the wall of the supply cycle. The original operational planning relied on a refresh rate, a supply cycle, of roughly 10 days. This was the time calculated for a transport column to load at a railhead, reach the front, offload, and return. However, due to the infrastructure gap and vehicle attrition analyzed previously, this cycle had ballooned to nearly 30 days. In systems analysis terms, the throughput efficiency had dropped below the survival threshold. Frontline units were receiving 1/3 of their daily caloric and ammunition requirements. We see this collapse vividly in the fuel crisis of late autumn. The data shows that the 4th Panzer Group, tasked with the northern encirclement of Moscow, was frequently immobilized not by Red Army resistance, but by empty fuel tanks. The situation became so desperate that the Luftwaffe was ordered to airlift fuel to the spearheads. From an economic standpoint, this was ruinous. Burning high-octane aviation fuel to transport low-octane gasoline is a negative-sum game, a clear indicator of a broken logistics system. The operational reach had officially exceeded the logistical grasp. When the Russian winter finally arrived, it merely buried a system that had already failed. The catastrophic freezing of the German locomotives provides the final damning evidence of this systemic blindness. German locomotives were designed with external piping and plumbing suitable for the mild climates of the Ruhr or the Rhine. When temperatures dropped to 30 degrees C, these external lines froze and burst, turning the trains into useless blocks of ice. In contrast, Soviet locomotives were designed with internal plumbing, insulated by the boiler's own heat. This was not a misfortune of weather. It was a failure of industrial foresight. The collapse of the rail network meant that even if the factories in Germany were producing winter clothing and antifreeze, there was no delivery mechanism to get them to the freezing soldiers at the front. The archives of the Quartermaster General record thousands of tons of winter gear piling up in Warsaw and Minsk, while men froze to death 500 miles to the east. Ultimately, Barbarossa proved that amateur strategy discusses tactics, but professional strategy discusses logistics. The Wehrmacht achieved a tactical kill ratio that was historically unprecedented, yet they lost the campaign. They attempted to defeat a continental power with a logistical system designed for a regional conflict. The 10-day supply cycle was a tether. When the army stretched it too far, it didn't just stretch, it snapped. The Wehrmacht did not lose because they ran out of courage. They lost because they ran out of trucks, tracks, and time. In the end, the study of Operation Barbarossa strips away the veneer of martial glory to reveal the cold, hard machinery of war. It reminds us that battles are not decided solely by the caliber of the gun or the courage of the soldier, but by the humble, unglamorous capacity to move supplies across a map. When ambition outpaces the supply line, the system invariably collapses, proving that in the equation of conflict, The tyranny of distance always holds the casting vote,